Chrysler, Evaporative System Integrity Module. Chrysler replaced their natural vacuum leak detection module with the ESIM about 2007 and later. It depends on the vehicle. Newer vehicles will have this. The idea is to replace the springs in the natural vacuum leak detection with check valve. The ESIM module is a mechanical method of measuring small vacuum levels by using check valves that seal by their weight setting on a valve seat. Let me say it again. There are no springs. It's the weight of the check valve that calibrates them and sets them on their seat, and they will lift off their seat with either pressure or vacuum. And we have a vacuum-operated switch that closes around 0.8 to 2.2 inches of water. It's present at the inlet to the canister. Everything going in and out of the canister is going to go through the ESIM. The pressure check valve opens about 0.5 inches to permit refueling and to relieve any pressure during our natural vacuum leak detection action. This is exactly what happened in the natural vacuum leak detection. There we had springs. The sealing force is gravity. Remember, I've said the weight and the angle is necessary to keep it closed. There are no springs involved, so the canister angle and the module angle on the ESIM module is critical. Don't change that angle. Here's what it looks like in vacuum mode. In vacuum mode, air is coming, or vapor is coming from the canister through the check valve, 0.8 to 2.2 inches of water, and going into the fuel tank. And at the same time, it's closing the switch. This is the action that would take place during natural vacuum. It would indicate a natural vacuum has formed. Now you're looking at the vacuum switch under the diaphragm there. That diaphragm is activated by vacuum and is going to close the switch when the vacuum is present. So let's look at the components laid out here. We can see them. The large check valve is for the 0.5 inches of pressure for refueling. It's going to lift off its seat and allow pressure out. We'll show how that works. The smaller check valve is for vacuum, 0.8 to 2.2 inches of water. And at the same time, the vacuum is moving the vacuum check valve. It's moving the vacuum switch through the diaphragm. Here's what we look like. We have pressure. We're refueling, or we've shut down and we're leaving pressure for our natural vacuum. Pressure from the tank lifts the larger one off its seat. Notice that the pressure would be pushing down against the small one in the bottom. It's a vacuum sensor, so the pressure keeps the vacuum sensor closed, opens the pressure sensor. The pressure does not close the vacuum switch because it is not a vacuum, and we've sent the vapor from the tank out to the canister for storage. This can happen after shutdown. This is our first part of our natural vacuum leak detection system. Then if we cool the system off when the fuel's been hot, we're going to relieve any pressure. It's going to vent early in the cycle, just like we did with Ford. We had to go through and see if we had a pressure rise. Here, just like in the natural vacuum leak detection, the diaphragm opens, or the check valve opens, relieves the pressure, keeps it no more than a half a psi. Then we're going to develop a vacuum as the fuel cools, and we'll go into our cycle. Fuel as it cooling is going to drop below the 0.5 inch threshold, and the pressure check valve will close, sealing the inlet to the canister. And then we're going to start developing a vacuum. As the vacuum develops, if we get to a 0.8 or 2.2 inch of vacuum, we pass the test if we get enough vacuum. A weak 0.8 to 2.2 develops as it cools. And if that happens, there are no leaks and we pass. Now, just as a reminder, 3 degrees Fahrenheit temperature drop in the fuel will create about 1 inch of vacuum. So we need about a 5-degree drop in order to get this to work. It may take as long as 4 hours. Hot fuel creates a natural vacuum than cold fuel, and the enabling criteria includes vehicle operation for at least 10 minutes with the vehicle in motion to heat the fuel. So we've got a very simple enabling criteria. The vehicle is driven, and then we're going to set our test lines. ESIM input's pretty simple. We got the switch that closes, indicating we've reached 0.8 to 2.2. This is going to be a low power, keep alive section of the PCM that runs when the engine is shut off. There are several different calibrations with different vehicles. There are only 2 pins in these connectors. There's not much to them. We're just looking at the switch. Do not mix and match these. They're calibrated for the specific vehicles they're hooked up to. So natural vacuum. If we create this a 0.5 watt 2.2 inches during cool down and close the switch, we pass the test. and the sieve accumulates the time and determines the pass or fail based on driving time for heating the fuel, ambient temperature for cooling. So we need to have 10 minutes of driving time. We want to see the fuel heat up. We want to see it cool, and the computer is going to accumulate all of that. It may take as many as 10 consecutive failed attempts at developing a natural vacuum to set a code with short trips. Keep that in mind. It is not infallible. During normal purge operation, the PCM observes the vacuum switch closing as a check for a gross leak. If we can close this vacuum switch 0.8 to 2.2 inches, we pass the gross leak test. So this works without any springs, simply by the weight of the two check valves, a pressure check valve and a vacuum check valve, and a vacuum operated switch.